Determine the voltage VR of t and Vc of t for t greater than or equal to 0 when switch is moved from position 1 to 2 for the network shown below. This is the given network, and here we can find that there is a switch and we have two positions, position 1 and position 2. So here we need to calculate VR of t, that is voltage across 5000 ohm resistor, and Vc of t, that is voltage across capacitor, when switch is moved from position 1 to 2. So here it is seen that at t equal to 0 the switch will move in this direction. It means that the switch is connected to position 1 for t, that is for t less than 0, the position of the switch is connected to A. So we can say that at t equal to 0 minus, the switch is connected to position A. Let me draw the circuit. So this is the circuit at t equal to 0 minus, that is at t equal to 0 minus, the switch is connected to position 1. So when switch is connected to position 1, the circuit is in steady state, that is the circuit is in steady state. So we know that at steady state, if there is an inductor, it acts like short circuit. If there is a capacitor, acts like open circuit, and resistor behaves same. Therefore here I have shown the capacitor acts like open circuit. So here I have removed the capacitor and I made it open. The capacitor acts like open circuit. Therefore I made it open. So here the capacitor acts as an open circuit, so I made it open. So this is the open loop, no current flows in the loop. So voltage across this portion is nothing but 100 volt. So we can call it as Vc of the t is nothing but 0 minus, that is Vc of 0 minus will be equal to 100 volts, because current in the circuit is 0. This 100 volt is nothing but voltage across these two terminal, that is Vc of 0 minus, which is equal to 100 volt. But we know that Vc of 0 minus is same as Vc of 0 plus, that is voltage across capacitor immediately after switching operation will be same as before switching operation. Therefore Vc of 0 plus is nothing but 100 volts. Now here it is seen that at t equal to 0, switch will move from position 1 to 2. Let me consider the position of the switch which is connected to 2. So here I have shown at t equal to 0, the switch will move from position 1 to 2. The circuit looks like this. So let me assume the current in the circuit is, say, I of t. So now we supposed to calculate I of t first. So for easy simplification, I will solve this problem using Laplace transform. So I will try to represent this circuit in S domain. That is, let me represent above circuit in S domain. So in S domain, this 50 can be represented as, constant can be represented as 50 divided by S. And here we have resistor. Resistor should be kept as it is, that is 5000. And here we have a capacitor. Capacitor value should be replaced by 1 over Cs. That is, C should be replaced by 1 over Cs. So here C value is 1 microfarad. That is 1 into 10 power minus 6. We have S. So here we can see that there exists an initial voltage across capacitor which is 100 volts. So if there is an initial voltage, there exists a voltage source of magnitude 100 volt. It can be represented as V of 0 minus divided by S. So here v of 0 minus is 100 and it is 100 by s. So here I of t in s domain, we will represent it as I of s. So now I will apply KVL to this circuit, that is apply KVL to S domain circuit. So let me start from voltage source, that is 50 by S is equal to, we have voltage across 5000 is 5000 into I of S. We have 5000 I of S. Here we have 1 over CS, that is plus 1 upon C is nothing but 1 into 10 power minus 6 S into I of S, that is voltage across this is I of S into 1 over CS, plus we have 100 by S. There is a voltage source, that is plus 100 by S. Now let me simplify this. We have 50 by S minus 100 by S is equal to, I'll take I of S common here, I of S, so I can write it as 5000 plus, so I'll take 10 power minus 6 on numerator, it will become 10 power 6 divided by S. So here I can simplify, I can write it as minus 50 by S is equal to I of S, we have 5000 plus 10 power 6 by S. Further I can represent it as I of S is equal to, we have minus 50 divided by S divided by this whole term, that is 5000 plus 10 power 6 by S. Or I can represent it as minus 50 divided by S divided by, here I have 5000 S plus 10 power 6 divided by S, that is I have taken S as a LCM. So I can represent further I can represent it as, so this S will go on numerator, this S and this S will get cancelled, will get minus 50 divided by 5000 S plus 10 power 6. Let me simplify this further. So further I can represent it as I of S is equal to, so here on numerator I will keep minus 50 as it is, that is minus 50, and in denominator I will represent it as, I will take this 5000 outside the bracket, that is 5000, in bracket I will write S plus, we have 10 power 6 divided by 5000, which is same as previous expression. Further I can simplify this as I of S is equal to, here minus 50 divided by 5000, it gives minus 0.01 divided by the remaining term, I will write it as S plus, that is 10 power 6 divided by 5000, it gives 200. Further I can represent it as I of S is equal to minus 0.01, we have 1 upon S plus 200. So now let me take the inverse Laplace transform of this, that is taking inverse Laplace transform. So inverse Laplace transform of I of S is I of t is equal to, this is constant kept as it is, minus 0.01. We know that Laplace transform of e power minus at will be equal to 1 over s plus a. Therefore, inverse Laplace transform of this will be equal to e power minus at. If we compare with this expression, here it will be same, that is 1 over s plus a. So here a is nothing but 200. So inverse Laplace transform of this will be equal to e power minus at. So inverse Laplace transform of this term will be e power minus a. A is nothing but 200 t. So this will be minus 0.01 e power minus 200 t. This is the current which is flowing in the circuit. Here it is asked for VR of t and Vc of t for t greater than 0. So Vc of t is already found for t greater than 0. That is Vc of 0 plus. That is nothing but 100 volt. So Vc of 0 plus is already calculated. Now let me calculate VR of t. That is voltage across resistor. So therefore we can write VR of t will be equal to voltage across 5000. That is voltage across this will be 5000 into I of t. So I can write 5000 into I of t, or I can write VR of t is equal to 5000 into I of t is nothing but that is minus 0.01 into e power minus 200 t. So therefore I can write voltage across resistor is 5000 into 0.01, it gives minus 50 into e power minus 200 t. This is the required result. Thank you for watching.